All right, guys. So as you can tell in these meetups, we like to have fun, and we like to hang out and talk things, all things Snowflake. And so this one tonight we put together, we actually had quite a few people from the last several meetups talk about UDFs and some of the new features that kind of came out for them. And so we're just going to kind of like really touch the surface. I mean, we could dive into this probably a little bit deeper, but if we have time at the end, maybe we can. And then of course we can always set up another one to really get into UDFs and how Java and Python really can be helpful to integrate and act as good clients for Snowflake. So if you guys have been here before, we just kind of go over some super quick fun rules. Everybody's respectful, everyone's trying to have some fun. If you have a question or want to chat, typically post it to everyone so everyone can see it. You don't have to turn your video on. We recommend next time you come, you invite a friend or recommend us. And then of course, ping us on Twitter and all social media. We're over at Data Lakehouse. And but for tonight, yeah, we're just going to cover a few things. I don't know, typically these go about 30 minutes to an hour. We might find a nice sweet spot somewhere in between there. And so we're just going to hit a lot of the high level topics or high level coverage on UDFs, user-defined functions, UDTFs, talk about some of the use cases and how some customers are actually using it and why we like them. And then, originally we talked about this to be focused specifically on Java, but obviously not everybody's a Java expert. So, talk about regular UDFs, but, a decent amount is going to focus on Java, and we'll walk through some stuff. I think we're going to hit the Jupyter Notebook tonight, but we'll see what happens. And then we'll do some walkthroughs, some real step through of code and stuff like that. So if we don't get to the Python visualizations, don't hate on us too much. We'll definitely bring it back in a follow-up meetup session. So, and all of our meetups, they get recorded, they get put out there for everybody to see. Again, hopefully you guys enjoy it, but definitely subscribe to our YouTube channel so we can keep getting feedback on these events and how we're doing and so forth. So, well, just real quick, again, I think everyone here is probably a little bit familiar with Snowflake, but your mileage may vary on your experience. So what is it again? Super high level. It is the data cloud, right? Data warehousing in the cloud. So it's a perfect tool for ingesting data, continuous integration, definitely some key ways to govern the data that's flowing into the system. If you guys haven't checked out tagging, that's really cool. I like to throw that out these days just for people who aren't aware. And then of course, it's a great way to access data across all of your customers, all your internal systems, for any apps you're building. And then it's got near infinite scale. So pretty much all of your workloads that you've been doing with data integration and so forth can be put on a Snowflake. So it's a really awesome platform. And at the end of the day, it's really out there solving a problem of getting data out to consumers in many different ways, but then also in doing what it can to ingest the data, transform the data, normalize the data, provide all sorts of analytical functions and capabilities, and getting that into one single platform so that your data consumers can do their most effective jobs with that data, turn it into information and such. So super fast, speed round what it is and what problems it solves. But we're here to talk about UDFs inside of Snowflake. So let's get to that. And Mike, am I turning this one over to you? I can't remember, but we'll start with this first bullet point anyway.
Yeah, absolutely. You I can have an egg jump in where needed, but just in general, just want to set the expectation of, well, what is a UDF? Why is it important, or why is it interesting, or why is it even a big deal from the context of running these from within Snowflake? And you think of UDF, and we'll also talk about UDTF as well. But just think of user-defined function. Think of these as reusable code. It's more than just, oh, I want to do some processing within Snowflake. I have some SQL. It's far and above that from the context of you can be able to do a lot more than just SQL, for example. But you're really, building out, and then so there's user-defined functions, there's user-defined table functions, similar to the UDF, but really you're looking at returning a set of values, or think of more of a temporary table. And then we're also calling external functions as well. So calling out to whether it's GCP, Azure, AWS, and really you already have code that's written, or somebody in your organization has already written code. And instead of going through a very long, tedious process that may not even be possible to try to recompile that and get it to run within Snowflake, you're just calling out to these external functions. So really unleashing the power of what you've already created within other applications, but all running all of that from within the context of Snowflake.
Absolutely. And I really like the user-defined external function capability, because you could think of it like exactly what you're saying, Mike, right? Like you could call out to an existing AWS Lambda function. Like we've done some cool stuff there where we're doing like natural language processing by just passing it to Lambda function, right? Just written in Python, at least Lambda function is. And then, calling some sort of NLP library, doing some cool stuff like that. So that's a small use case, but it's a pretty interesting one of just like what you can do inside of through Snowflake itself, but you're doing it inside of Snowflake, right?
No, absolutely. There's definitely some other use cases. If we tap over to the next slide here, when we talk about, Christian mentioned, some of the natural language processing. There's also training your models. So think of from a data science perspective here, the ML component, where perhaps you're scoring data or you're looking for anomalies within the data itself here. All of that is done upon load within Snowflake. And you're really leveraging all the power of things that have essentially been created outside of Snowflake. And of course, you may have written some things within Java and Spark, like, oh, wow, okay. If you've come from the Hadoop world, you will have a lot of this sitting within your organization. And as much as Hadoop has gone down a sunset route, there's still a lot of valuable code that's been written in, and you're able to continue to leverage that within calling these Java UDFs. And just like Christian mentioned, the calling out to Lambda. So we can jump to the next slide.
Yep.
And then there's even more advanced things. Think of, all right, you're doing geospatial, you're trying to put shapes onto a map, calculate distance between 2 points. All right, it's interesting. Obviously, just even think from a casino floor perspective. You're trying to figure out, all right, what's the layout of that casino floor? Where's really, do I want the certain dollar performing games and machines? And to calculate all that, using data on the surface sounds pretty crazy, but it's a very legitimate business case. And as much like a lot of organizations get no shortage of Excel and PDF files, and trying to parse out a lot of that data can be very laborious, and a lot of code that's been written, especially if you're a larger enterprise organization. We already have a lot of these parsers. You can just leverage that parsing within Snowflake via the UDFs.
Then I'll cover this one in a little bit, storing Java libraries and stages. So you could take one of those libraries and plug it on in. We'll talk about that. Ooh, walk through with me. Okay. Let's see here. So we've got a couple of items we wanted to cover. So we're going to create a basic UDF and SQL. I think that's actually true, but I can run that one too if you don't have your screen up. And then we're going to create a Java UDF. And I think we're going to get into Notebook a little bit, but we might just spend enough time on the UDFs themselves, and I might not get into the Jupyter aspect of it, where we're just kind of basically leveraging some of the UDFs to plot out some stuff. So let's see which one is next here, and then we'll just walk over into that, because I think mine is after this one.
You can go into the next slide.
Okay.
So when we think of a SQL UDF, this might be the easiest type of UDF to start with from an example perspective, where really you're on the fly processing, potentially processing data. You're trying to potentially even look at a table. So think of a security table. Well, you're not going to necessarily let folks within the organization be able to arbitrarily query a security table. However, there might be some attributes of that table, number of records that may be of interest to an audience. You want to expose some of that functionality to, from a read-only perspective. They're able to set up SQL UDFs to do that. You also can, on the fly, do aggregation of certain data elements and their values, and put that into a table, so that UDTF perspective. So go to the next slide.
Yeah, so kind of like Mike mentioned, one of the biggest use cases I think out there for UDFs and UDTFs is security and the ability to, maybe you have a read-only table that only that you want to have some users be able to access, but you don't want them necessarily to have everything. So you do have the ability to maybe allow them to send in an input to a UDF and it returns a result or something like that. So security is one of these nice use cases for UDFs, UDTFs, but also just I think one of the biggest things with UDFs, UDTFs is the ability to reuse and recycle code. So if you are writing a nice long store procedure that you're going to have to write a certain piece of code over and over and over again, it's really nice because you are able to use a UDF, UDTF to consolidate all that code and simply be able to send in an input, kind of like you would a Python function or a C or C++ function. And the nice thing also with UDFs, UDTFs is they are, you can be able to use them within SQL statements. So if I'm running a select statement, you can say select and then the function name, and it will return your result like that. And we'll be able to see it in a demo in just a moment. But the other nice thing about UDFs and UDTFs are the ability to potentially improve execution times with the and depending on what SQL platform you're using, the ability to have caching or the kind of the platform remembering what the code is and what the results of the code would be, that improves execution times and allows you to be able to run queries a little bit faster. So Christian, if you let me share my screen, we can go into this demo.
All right, you are
up. Who's hosting? Is that Heather?
It's Heather's got the host on. Well, I actually started it, so let me see if I need to do security. Here you go. You should be able to do it now.
All right, thanks.
Yep.
All right, can everybody see my screen?
Yes, we see it.
Okay, great. So I wanted to just start with one use case, and I'm going to run a quick query. We're going to be using this transaction history table, which is just kind of an arbitrary listing of transactions. And the main column we're going to look at is this actual cost field. So we're one record in the table is consistent with one transaction, and like for row one, we're looking at a cost of $1,700.99. Well, let's say that we want to be able to kind of bucketize these transactions. We want to be able to say that 1,700 falls within the realm of 1,500 and 1,750, and we use that kind of that 1,500 to 1,750 bucket as kind of maybe a KPI for a BI a BI dashboard or something like that. This might be a nice way to allow a UDF to do some of the work for us. So we've got a little bit of code right here. I'm just going to highlight lines 7 through 28. And basically what we've got here is a UDF. So it is going to take in a field, or take in a column called, we're going to call it actual cost within the UDF. And what we're trying to get back is a varchar, or basically this this kind of bucket. So we're going to try and categorize all of our all the costs within the query. We're going to try and bucketize them and give them a category. So and you can see right here, we're just saying that when this input is between two values, then we want to put it in a certain bucket. So we can run this, and our function is created. And we'll actually use this function now to be able to input this actual cost field that we saw in the transaction history table. And we'll try to bucketize our transactions based on that. So we run that, and yes, so what we see is we've got kind of a bucketized transaction amount based on this, input of actual costs that we had from the transaction history table. So that's kind of one of the use cases, and this is just a UDF. So it means when we are sending in one parameter, we are expecting one parameter to come out. So in this query right here, we call the cost bucket function, the cost bucket UDF. We send in one value, and we get back one value. So the results of this query are going to be the exact same. And granted, I ran it on I filtered the top 100 results on it. But if we were to run it on the entire table, we would get the entire table back. So we're not going to get any filtering or aggregation or grouping done because we call this UDF. But I guess that leads us into a UDTF. So like Mike was saying earlier, a UDTF is user-defined tabular or table function. So what we get back, and the difference between that and a UDF is that we return a table instead of just one scalar value. So right here we are, creating a function in the same syntax that we did on the last function right here, create or replace function. We're doing it the exact same way here. We're going to call this one transaction totals by product. And we are going to return a table this time instead of just a varchar. So, and this is kind of where you do your table definition right here. We see we only want to return two columns, a product ID and a transaction count. And notice we aren't sending in any parameters on this one. We are just simply selecting from this table, from this table right here, this transaction history table that we were looking at on the previous example. So we'll run this. And we've created our function. So, and then the way that you query the results of the UDTF then are you use Snowflake's built-in table function, and you basically just select from, and then the results of the function called transaction totals by product right here. And so we do that. And you see we've got everything boiled down to the product ID level. So we do in this case do grouping and aggregation based on product ID, and we are trying to get the the number of transactions based on that specific product ID. So that's kind of the gist of the UDTF. And then we've got another example right here where we do a little bit more joining and aggregation, but it's in essence the same thing as what we had seen on the last example. So we're joining two tables, purchase order header and purchase order detail, and we are grouping by vendor ID this time, and we are trying to get a count of the purchases made by a specific vendor or each specific vendor. So this is going to return a table again. We're looking at just vendor ID and total order, or the column's called total order by vendor, but we're looking for the number of orders or number of purchases by each vendor. So we do that, we created our function, and then in the same way we queried the table using the last example of a UDTF. We can go here and we see that we have all of our vendor IDs and then the number of orders made by each vendor. And then one more thing I just wanted to point out was you can query the information schema query, which very handy at some points in time. But in here, we're able to see a few different functions that we created. And you can see specifically the functions that we made right now. So we made cost bucket, transaction totals by product, and we made one of these is the one we just made, purchase totals by vendor. So yeah, that's about it from what I have on SQL UDFs. I think we're going to go over to Java UDFs now.
Very cool stuff, Drew. And that one use case you had there with the bands, you know, that's such a popular use case, like in HR, like we see it all the time. Like, you know, what pay grade band is is an employee in, you know, that type of thing. So that's super helpful for sure, because that's something that gets repeated a lot in HR analytics. Can you guys still see my desktop? What am I showing?
What is a Java UDF slide?
Perfect. All right. Well, you know, one thing I thought about while you were doing that, Drew, you know, we really never in this meetup step back to kind of like, what is a function in general, right? I mean, Mike covered it, but I guess more of the baseline that there are system functions in, you know, all these databases and applications, and definitely in Snowflake in general, right? So if you've ever called coalesce or trim, or, you know, any other standard, like, you know, a database or Snowflake function, right? Those are system functions. So a user defined function is a user creating their own function that can be used just like a system function. So I don't know if we ever like mentioned that, but it's kind of like the elementary, you know, often abstracted, you know, reference to it. So anyway, hopefully that makes sense. But yeah, you know, great stuff, Drew. That really good coverage. Especially with the information schema. So a Java UDF, just to kind of throw it out there, very similar to one that you would do with plain SQL. We like it because you get to use your Java skills. If you have any people who are either need to dust off those skills or use it, or like to use and show off their Java skills. And you know, it's another way to compute or process the information that's coming out of your SQL query, right? And there's a couple things that I wanted to call out specifically on the Java UDF, having, you know, written Java for more than a decade now. But what's really interesting about the Java UDF, and we'll talk about it, and we'll see it just like we saw the SQL UDF that Drew was walking you through. One interesting fact is that it's a memory. There's a memory backed temp drive where you could, in essence, use that to read and write files, right? Kind of in the background. I always thought that was very interesting when we first started learning about these. Now, it's one of those things, probably, you know, your mileage may vary. It's probably not exactly like you're running like a Docker image behind the scenes and you can do whatever you want. There's probably limitations. You'll have to test that out. But for basic stuff, it actually works. There's a key term in programming called idempotency. Some people say it differently. I say idempotency or idempotent. If you've never heard of this word, go look it up. It's very very effective word for a lot of scenarios that happen in development. And I think SQL's in some ways can be a similar use case for idempotency. So take a look at that. But when you're using Java UDFs, it's something to think about what we've seen in practice, making sure that everything is just kind of like a singular or single reference to anything that you're creating there. We won't go through it in great detail, but there's some situations where, like, if you're running like multiple Java UDFs at the same time, or kind of like running things in parallel, especially if you're like writing files and reading files, like you have to make sure like file names are very unique, for example. So that's one of the core tenets of idempotency. Also, it's really working in a restricted kind of engine. I think the documentation refers to the UDFs that you're basically compiling your Java in, or working in a restricted engine. The only thing I could think of, if anybody's like really technical, like a Linux operating system background, is kind of like it's root jail type of situation. But I don't actually have an answer on that. I have to talk to one of the Snowflake engineers at some point on that. But it's just an interesting thought for Java developers out there to think about. And there's some other restrictions that are out there, like JNI is not supported. And in theory, you're not going to use it for making any network calls. So that's where maybe like an external UDF might come into play. And there's a few more things. I think the documentation is okay on UDF. So I think it really depends on what you actually are trying to do with the Java UDF. So I'm going to show like a super basic example, and I'm going to try to show kind of a more like a syntactical example of the Java UDFs, and try to take a look at things like syntax, compiling, data type considerations, and just kind of like what we're actually returning, which some people might find interesting, but we'll at least just take a quick look at it, and then we'll run an example. So very similar to what Drew was doing. I'm going to go ahead and kind of blow this up a little bit. Hopefully that helps some folks. So I think I'm using this current environment here as context. And so what I'm going to do is take a look at a similar data set to what Drew was looking at. And so this is basically like purchase order detail. If anybody's interested, I guess another thing to bring up, we put all of our code out on the GitHub repository. So anything that we're doing here will be out there in a couple of days as well, with a link to the recorded video, just in case anybody's interested in that. So here we have just a basic result set, something like you would see in a third normal form sales database for a company. And so we're looking at purchase order detail. We've got basic columns here. Won't go into great detail. And so what I want to do is just create a Java UDF that's going to do something with that data. Again, just like Drew showed for the SQL UDFs, we're basically going to integrate it within a SQL query. We're going to integrate the user-defined function call inside of a SQL statement to do some sort of repetitive operation or some process. And in this case, I just picked a very straightforward one. Well, it might not be straightforward or entertaining, but it's I think it covers the point of a very basic Java UDF. So I'm actually fully qualifying here. So we've got create replace function going down. So we've got database schema and then function name. And you might know or notice that, just like some other things like schemas, I think, and some other objects within Snowflake, a lot of them are schema based. So they're not at the database level, they're at the schema level. So our function here is listed at the schema level. And of course, if you're interested, you can always try to create the function at the database level and see what happens. So we've got the one here called get product cost. The logic I'm actually doing is different from cost. Actually, I'm trying to aim to do taxation. So I'm accepting 3 parameters here. So we've got X, Y, and Z. So we went ahead with different data types, and I'll go over why we did that here in a moment. So we've got 2 integers and a float. And so something to notice here is float is going to be our Snowflake data type for any sort of double precision. So if you're looking at like any sort of like dollar amount, something like that, where you've got a scale and a precision. So you've got a dot something. So, $5.36, right? You're typically going to use something like a float for that. And so we're actually going to return a float because, again, we're returning the Snowflake data types here. And so then we're also going to put language. And so our language is going to be Java. And then we're going to have a handler. So the handler is kind of interesting because it's really just referencing our class and our method or our Java function. And then inside of our kind of our action brackets here, we're going to go ahead and create, again, very basic. I think anyone who's taken kind of 101 in computer science can follow the syntax here. So we're just creating a basic class, giving the class a name, using our open bracket structure. We're creating a public static, and then we're going to return a double type. So if you look at your Java documentation, right, a double is going to be that kind of floating integer concept that's similar to a float in Snowflake data types. And so we're going to give our function a name. This is just the do something function. And then here we're going to take those 3 parameters and we're going to pass these Snowflake parameters into our Java parameters. And we're just going to do some basic math. So the goal here was basically to take two arguments, add them together, and then multiply them by some factor that's coming in here as a float. So this could be anything from like any type of like driver percentage. I want to see what happens if sales increase, by 7% over the next year or something like that. Or if you just want to say, hey, I want to see what the tax will be on this particular sales transaction that happened, right? So there's many different things you could do here, but that's the use case we're going for, the latter one with the taxation. So we simply run our create or replace function here. Everything should compile correctly. And if you think about that, so this goes to one of my bullets, this is actually compiling, right, in the back end. If it's not compiling, I really want to know how Snowflake worked that magic and parse that. Just for giggles, I'm going to run it without the schema, just in case anybody ever tests things like this, right? So we've got schema does not exist. So it kind of gives you the indication of where your functions actually live. Okay, so we've created that function. Let's create it again, just in case, or we'll replace it. So we're going to create it. And so now, just like what Drew was doing, we are going to take that data set I ran before we create the function, and I'm going to go ahead and just kind of pull out the ones I want to take a look at. And then I'm going to run this function. Now I'm fully qualifying it here, right? Drew, you didn't fully qualify yours, right? You just had the function name.
No, I just use the inside of the table function.
Yeah, because you were already in that context in your query.
Yeah.
But it works both ways, I think, is what we're highlighting. And then all we're doing here is simply passing in, I guess I'm passing in order quantity, unit price, and then I am passing in the, this is really percentage, right? Like just pure math, right? You're taking a number and then you've got the percentage, and in essence, that should be the addition of the percentage to whatever amount you're looking to get the increased percentage by. So, and then I'm calling that as a field as unit price taxed. So it's a very rudimentary example that we're running through. So you saw the result before. And so now if I run this, and I'm also looking at time as well, because here I did not limit my rows. So I knew there's about 10,000 rows here. And I'm using an extra small warehouse. So, all these things are factors in what we're doing here. And so when you think about using this for, performance, reliability, or just processing impact, you can think about that as the first time I ran it, came back in 2.2 seconds for about, it's about 10,000 rows. And then if I run it again, right, so come back a little bit faster, right, a little cache action. So it's still pretty fast, even though it's doing a very basic mathematical function. There's nothing crazy there. So if I were to do that same math in a standard SQL function, it shouldn't return that much faster, right? So when you think about performance, if anybody brings that up to you, I mean, it's going to be negligible, probably immaterial, especially over like, average data set sizes. So we've done user-defined functions over, very, very large data sets, and there's very little impact to processing speed or time. So that is the usage of a basic Java UDF. I mean, there's so much more you can do there. We didn't even get into calling like actual, like normally used Java libraries and things of that nature. But I'm going to step into this just kind of reference. We don't actually have a full-blown example here. Well, it's not one that I plan on running right now, and just for the sake of time. But also with the Java UDFs, you can actually import a jar file. So this one's actually interesting. We do plan on doing like another meetup just to kind of really go deep dive into this, but we don't want to steal the thunder from some of the other UDFs that are out there. And so just kind of talk about the way it works real quick. So basically what you're able to do is you can create a stage, just like a normal stage like you would have for importing, CSVs or JSON files or anything like that. And you would bring in a jar file. So you could create your jar file in Spring Boot. You could create it in Quarkus. That's our favorite Java framework. If you guys don't know Quarkus, check it out if you're Java aficionados. And then, or just plain on Pojos if you want to. And you would actually compile your jar. You would basically copy into or bring your jar into a stage. And then you can use that jar by referencing the stage like you would any other stage for like CSVs and JSON files, like I mentioned. You would simply use the import function, locate your jar, and then locate the class path for which that jar is created under, or the method in the class under which it's created. And then you would just very much use your call to the function, very similar to what we're doing here, to run that syntax. So this is just an example. You create the function called show me the money. This could be, a basic algorithm. It could be an NLP. It could be anything that Java is really running in that compiled library. And then you basically pass it in and it'll run, it'll pass that string or whatever you have into this method that you're calling here. And then it'll return your information. Sorry, we don't have a great example for you running on that one, but another great use case for Java UDFs. Okay, cool. So back to the slide real quick. I think I had a sample of this here. So that's kind of what that syntax looks like that I was showing a minute ago. And let's see, okay. Drew or Mike, what are we doing on Python? Do we have Python to look at? Anything on the notebooks?
I've got the notebook and I can run through it real quick if you guys want.
Sure, yeah, we've got a few minutes left before we drop. Anybody in the group have any questions while Drew's pulling that up? Anybody used UDFs like big time, or any fun use cases you want to talk about? We love hearing stories from the real world, or even the prototype world. Any prototypes anyone's done with UDFs? Okay. All right, Drew, what you got? Can you share your screen?
Yeah, one moment.
Okay, no worries.
All right, can you guys see my screen?
Yes.
All right. So I think that the big thing here is the ability to kind of be able to put this in a Python or Jupyter notebook and to be able to kind of just step through it. I don't think I'm going to run any code, but I'll at least step through kind of the pieces and the cells that we've got within the notebook. So, we just, if you're familiar with Python, we start by importing a couple libraries, the Snowflake connector and pandas. If you're not familiar with Python, basically what we're doing here is we're grabbing two libraries, one that's going to be able to allow us to connect to our Snowflake instance to be able to grab data, and then another called pandas, which is really nice because it allows us to manipulate, modify, aggregate data frames within Python. And that's going to be helpful. And you'll see that in just a moment. But we start by, enabling our Snowflake connection, and we've just kind of masked out the details there. But assume we've created a connection there, and we are then trying to be able to create a cursor object, which is going to allow us to run queries against the Snowflake instance, which is what we're doing in this cell right here. We are executing a couple statements, and you saw us doing that earlier, where we are trying to use the account admin role. We're trying to get the database DLH demo sandbox, and we're trying to use the Anapov warehouse. You can tell who illustrated or orchestrated this Python notebook, but yeah, from there we can, since we've got our connection created, we've got our Snowflake credentials in, we've got our everything kind of set up with Snowflake. We're then able to go ahead and start creating our UDFs, and this function UDF, this UDF is pretty, it's a UDTF. This one's pretty familiar because this is the second one that I ran, which allowed us to get counts of transactions by a specific product. So we're grouping by product ID. We want to get the count of however many transactions for each product ID in that transaction history table. So we go ahead and we run this. It creates within Snowflake, and then we are then able to execute a query right here. So it's the same query that I ran that we just did a select star on the UDTF. So it returns a table. We are selecting all of those records in the UDTF, and pretty straightforward. But then what we're doing in this next step is we are essentially using pandas to grab the results of that query, the query execution that we just did. So, so we executed this on the Snowflake end, and we, and I'm not 100% sure how this works on the back end, but we, through our Snowflake connector, we have access to this data that is from the UDTF, and we are asking the Snowflake connector to fetch it and put it in a pandas data frame right here. So that's what we do. And when we call the shape function, which is, I believe it's pandas as well, we see that we've got 441 rows and 2 columns. And when we call the columns function, we see that we've got product ID and transaction count as our columns, which corresponds to what we saw from the UDTF return or result set. So everything looks good there. And now right here with this code, we are asking we're asking to set up a plot basically. So we can then see the product ID and the number of transactions on the y-axis, get product ID on the x-axis, number of transactions on the y-axis, and there we've got kind of a basic plot of what we had with our result set of a UDTF. So, and then this next, I guess, section of code is we've got the third I guess the second UDTF that I showed in my previous demo, and we're doing the exact same thing. So we're asking Snowflake to execute this, and then we're trying to grab the result set of the purchase totals by vendor UDTF, and then we put it in the pandas data frame. We get its shape. It's got 86 records and 2 columns. The columns being vendor ID and total order vendor. And then we do the same thing again. We put it in we put it and plot it on a bar graph, and we've got our results there. So yeah, that's about it.
Very cool. All right. Yeah, and we always get maybe this group is very similar, but everybody's very interested in Python. I think it's kind of a ubiquitous language these days, and the more we talk about Python, those are typically the groups where we get more turnout at our meetups here. So that's kind of an interesting correlation, I think. So I don't know if anybody has any questions, but just kind of wrap up with UDFs for this meetup, our holiday meetup. I think we talked about the benefits, Java, Python, reusing skills on the internal teams, and then of course, the integration is just awesome, right? We love Snowflake because that integration, appears to be so seamless. And again, the leveraging of the skills and being able to reuse code, that's awesome too. So we talked about Java UDFs, we went over SQL UDFs, we had some of the Python integration, again, like what Drew showed with pandas, and some plotting and just pure execution of getting the data from Snowflake and calling those functions against Snowflake via Python. So very cool stuff. Let's see, we'll just keep wrapping up, and if anybody has any questions, jump in. So yes, so we're starting to create kind of a nice little code base over here. This is the link to our ASCG meetups and webinars. Check it out. Give us a star. Let us know if there's any issues. We love people who check us out and want to contribute. So, and if anybody ever wants to contribute on the meetup, definitely let us know. We're happy to have folks. We're trying to get a few Snowflake engineers to our meetups as well. So if anybody's got some good topics or some advanced topics and they'd like to get the good word from anyone from Snowflake engineering team, just let us know. We can try to get somebody to join us maybe in the new year. So I'll just open it up, see if anybody's got any Q&A or any questions. And I guess we've got a few more minutes here, or if not, we can go ahead and wrap up while people are thinking about their thoughts. Heather, what do we have coming up in the next couple of months by way of events? If you don't have it on the tip of your tongue, that's okay.
Yeah, I do. I have it pulled up somewhere over here. Let me see. So yeah, we have financial forecasting using Python and Snowflake coming up on the 17th of January. And then we're mixing it up a little bit and doing a second event in January. And we'll be talking about data lakehouse on Snowflake. And that's going to be on a Wednesday at noon instead of our regular 6 p.m. Meeting on a Monday. So we're going to kind of test things out and see what works best for everybody in our group. And if anybody has any feedback on timing and days that work better for them, please give us some feedback. We would love to hear it.
Well, I saw a few things go through the chat, but I think if there's not too many other questions, we can go ahead and wrap up and just say thank you all for joining, hanging out. Great job for everyone who was presenting. Everything's awesome, looks good. And feel free to reach out to us, guys, on social media if there's any questions or anything we can discuss with you. We'll go from there. We'll see you on the next one. So thanks, everybody. Have a great night, and happy holidays, of course.
Yes, happy holidays, everybody.
Yeah.
All right, thank you. Bye-bye.
Thanks, everyone.